Okay, so let's get into it. This is the week 4 screencast on undetermined coefficients. So let's get into it. Move this so we can see. Okay, so what I really want to do is I want to link this to what we were doing from last week, because that was kind of, I just feel like that's important. So last week we learned about the second order non-homogeneous differential equation, which is where it's not equal to 0, it's equal to something else, usually a function, which is basically this portion of my notes right here, right? And so this is what it looks like in the form of this. And then this is how the solution looks. It's a y c of t and then y p of t, right? And this p of t thing was, I guess, like a particular solution, but last week it was referring to any one solution. So you would get one solution, but you really couldn't figure out, like you couldn't control what you got, but you would get one, but it could be any one. But so for this week, now we want a specific any one. We want to control which one we get. And because this f of t, what it's equal to, is now more complex. And so what determines what makes something solvable by undetermined coefficients is this: if this f of t is a polynomial exponential sine or cosine function, and it can be a combination of those, it can be an addition or a product of those things. So the steps to solving them, the two that are the most important because they actually are unique besides just like plugging in, are finding the general solution for the corresponding equation, which is where you take, it's the complementary equation, which where you find the homogeneous version of whatever non-homogeneous equation you have, and that's going to be y of h. And then the second step, which is really, really the most important, because if you get this wrong, you can't get the question right, is finding the appropriate form of the particular solution and to determine the derivatives. Because in this case, what our solution is going to look like is just down here. It's just y of t equals c1 y of t plus c2 y of t, and then this yp, right? Which is still the form of yc plus c yp, the pt, but see, because this whole thing is y of c, but then this y of p is more complicated to find because f of t is a little more complicated. So based on our types, we can have an exponential, which, like, an example of that is 3e 2t, right? And the form that that's going to take is a e to the 2t, most simply. The next one is a polynomial, which is an example, which I'll also use in the example problem, is 4t to the third. And so basically how it's going to appear is its form is going to be, you're going to input a general form polynomial to whatever power is like f of t, because it can be, t to the second, t to the fourth, whatever. So as long as your first term is what you have like here, you're good. And it's usually a, b, c, d, whatever. So then you have your sine and cosine types. They scared me, but it's whatever. So how this works is, if you're going to have either a sine or a cosine in this, your answer, your form is going to have sine plus something cosine. And we'll get into that in the example, because I thought this would be an important example, because this is just trig is, people are like, oh, trig, gross. And then you have sum. So sum is more of like what you can do with sine polynomial and the exponential. And so think about it like this. So your f of t is a function plus another function. So what you do is then you create two different equations where you have one equation equal to the first part of the addition sum, and then the other one equal to the second one, and then you solve those, and then you put those together like that, and that's how it works. Okay, so basically, like I said, most important thing to remember is your homogeneous corresponding equation and your particular, getting the form correct for y of p. So let's do an example. So this example, first, I just want you to pay attention to, pay attention to the right side first. You have 4t to the third sine of 3t. So you're thinking of it like this. You have two functions, right? You have your polynomial, which is your 4t to the third, and then your sine and cosine, which is sine 3t. So what I would do is, since I know sine of 3t is like, you're going to have a sine and a cosine, which I've kind of like drawn arrows. You're going to have like space sine of 3t plus space cosine of 3t. So then what you do is, you're like, okay, polynomial, I have a third order polynomial. So I'm going to input a generic polynomial form, which, third degree polynomial form, which is this plus this. Right. So that's basically step 2, is getting the form correct, which is this polynomial, general polynomial, and then your sine cosine. And then you're going to look at your left side of your equation, right? And then you're going to this is where you work on your homogeneous complement, which is the step 1 over here. So you set up like this, and then you get, this is your C1, C2, right here. This is the homogeneous complement. This is what this is going to give you. And then you have, you're solving for over here, your y of p, which then this y of p is this. And then just for the length of the video, this is the most important part that's specific to undetermined coefficients is this. And then you're just going to plug this and this together, and that is it. So cool. Hope you have a great week. Cool.